Commercial aviation moves billions of passengers yearly. The physical volume of fuel burned leaves an enormous footprint across the upper atmosphere. Right now, standard fleet operations heavily rely on standard jet fuel profiles. The short-term math makes it convenient to use operational workarounds rather than tracking exact batch-specific fuel chemistry for every flight. But treating fuel chemistry as a purely administrative detail introduces extreme financial and logistical risks, especially as the European Commission prepares to finalize its new regulatory computations. Aviation carbon accounting is currently undergoing a massive structural shift. Under the new Monitoring, Reporting, and Verification Rules, or MRV, regulators now incorporate non-CO2 impacts, specifically soot and contrails, into the standard emissions ledger. During this critical baseline setting period, if an airline fails to provide specific refinery data for their fuel batches, the regulators do not leave the ledger blank. They apply a statutory default value. Left, a standard flight produces base CO2. Right, Eurocontrol models assign the same flight a massively inflated carbon dioxide equivalent footprint. This happens because warming impacts from soot and contrail cirrus equal or exceed the flight's direct CO2. Relying on default reporting values guarantees an airline's operations will appear drastically dirtier in public registries than competitors who track precise low-emission metrics. To understand how severe this penalty is, we must look closely at the MRV administrative mechanism. When a carrier leaves the batch-specific chemistry fields empty, the system makes an aggressive assumption. Bypassing actual chemistry data triggers an incomplete compliance form. The system rigidly stamps the airline with statutory maximums, 25% aromatics and 3,000 ppm sulfur, a strictly worst-case scenario that maximizes theoretical particulate emissions. This data submission is heavily governed by the sweeping regulatory authority of the European Union. Under Commission Implementing Regulation 2024/2493, strict accuracy regarding fuel burn and chemical composition is a hard legal mandate. The regulation places signed personal legal liability directly on airline executives for the validity of the submitted figures. Constantly signing off on worst-case default figures damages external optics. It signals to investors, climate litigation groups, and passengers that the carrier is making zero physical effort to mitigate its non-CO2 impact. Treating these default values as a harmless accounting shortcut actively exposes the airline to greenwashing litigation and direct executive liability. European regulators are highly calculated. Rather than taxing chemical aromatics directly, they intend to tax the specific environmental outcome caused by burning those aromatics. This diagram illustrates the automated engine driving this translation, the Non-CO2 Aviation Effects Tracking System, or NEATS. It routes 3 distinct data streams into a central processing node called the Contrail Cirrus Prediction Model. The first input stream is the data reported by the airline, meaning those high aromatic and high sulfur defaults. NEATS cross-references this default chemistry with exact flight paths, specific cruise altitudes, and real-time ambient humidity corridors. Inside the central node, the COSI-SIP model analyzes these intersecting variables to determine exactly how dense the resulting soot will be and how many hours the ensuing contrails will survive in the atmosphere. The system processes these environmental inputs and generates a singular numerical score for the flight, displayed as a global warming potential metric. Burning high aromatic fuel through a sensitive, humid atmospheric corridor creates ice crystals and trapped heat that drastically amplify this final score. Regulators have taken invisible particulate emissions and successfully translated them into a rigid, undeniable mathematical variable. The next step in the European blueprint takes that abstract environmental impact score and converts it directly into a measurable metric ton value of carbon dioxide equivalent. A flight burning a default 25% aromatic fuel blend through a highly sensitive atmospheric corridor triggers a massive penalty. The model applies an extra 1.5 to 2.0 times multiplier onto the base CO2 profile of the aircraft. Under the anticipated expansion of the EU emissions trading system, these mathematically calculated non-CO2 tons will be officially pulled onto the airline's financial ledger. We can see how this works on a sample ledger. The baseline scenario starts with 10,000 tons of direct CO2 emitted from standard operations. Because the carrier reported a high aromatic default chemistry, the model adds 12,000 tons of non-CO2 impact directly below it. The allowance surrender obligation jumps to 22,000. Now apply the real-world financial multiplier. With historical EU ETS allowances pricing between 60 and well over €100 per ton, this extra carbon footprint multiplies into a multi-million euro penalty. An airline that hasn't secured verifiable low aromatic fuel will watch its financial obligations skyrocket overnight once the system officially goes live. The EU ETS ledger takes what many carriers perceive as a minor administrative shortcut and turns it into a catastrophic operational liability. There is one viable way to avoid this algorithmic penalty, and it relies on proactive physical mitigation rather than regulatory paperwork. This timeline compares two strategies. The red trajectory shows the default baseline exploding upward, while the green trajectory remains stable using verifiable SAF blends. By injecting these refined blends, executives prove a physical reduction, entirely bypassing the NEATS multiplier trap. For airline executives, locking in clean fuel chemistry today operates as a legally binding financial insurance policy against future compliance costs. Waiting until the European Commission finalizes its computations guarantees an artificially inflated baseline, one that will be nearly impossible to course-correct once the penalty cycle begins. Fleet economists and route planners now face a critical question. How will you recalibrate long-term operational models to account for this monetized non-CO2 impact? Operators must look closely at how Refuel EU mandates and international blending limits intersect with these massive financial liabilities before the baseline is permanently locked in.